Hello guys, in this video we are going to connect to a real database in Node.js Express, and then we write the code to perform CRUD operations, that is to create, read, update and delete using REST API and the database we are going to connect to. What I have on the screen is a very basic Express.js application setup with 3 or 4 files which I'm going to explain before we get started. But if you don't know how to create an Express application, I suggest you check one of the previous videos where I covered that. Alright, talking about the files I added here, the first one I want to talk about is server.js. In server.js file, we are basically starting the server, telling the server to listen on port 3000 unless otherwise specified in the environment variable. That means we can visit localhost 3000 to access the base URL of this application. And then in the app.js file, this is a typical thing, we import Express and we create an instance of Express. Then down here, we've covered router in one of the previous lessons. I made a to-do router, right? We import it here and we mount it on the path /todos. And finally, for the REST API, we are going to send JSON data. This is telling Express to pass the JSON data. Talking about the router, let me go inside the router. Here we just defined a bunch of endpoints for our CRUD operations. Endpoint to create, endpoint to fetch all the records, endpoint to fetch a record by the ID, the one for update and the one for delete. Right now they don't have any logic because we haven't implemented them and we don't have the database connection set up. For now, if you call any of these endpoints, it's going to return the text not implemented. And then I have this DB folder. Inside it is migrations folder. Here is basically the SQL for creating the to-dos table. We are going to make use of this later. This is not really like proper migration where you have action and rollback and stuff. Just a convenient way for us to create this table in the database later. Finally, I want to mention that in the package.json, I am opting into ES module so I can make use of import statement instead of require. That's what this guy is for. And for the command to start the server, I'm using nodemon to watch for changes. So I have nodemon installed as dev dependency so that when there is a change in the code, the server will restart. All this other stuff you are seeing here is just for us not to append.js when we import a file. For example, I can use import app from app instead of import app from app.js. So we don't need to append that .js in the import statement. So that's my command to start the server, and that's basically it. So let's get started. To work with a database, we have different databases out there, different options we can choose. But for the purpose of this demonstration, we are going to make use of one of the most popular, most widely used out there, which is PostgreSQL. To do that, let me go in this DB folder and create a file. I'm going to call it index.js. I want to have in this file the codes for connecting to the database. To make it easy to work with Postgres in Node.js, we can make use of this Postgres client called Node Postgres. To install it is simple. We just run the command npm install pg. pg is for Postgres. So I'll head over to the terminal and run npm install pg. In addition to that, I'm going to install .env so that we can have the secrets for connecting to the database in a .env file and load it in the code where it is needed. So I'm going to say npm install .env. Let's head over to the code and make use of those packages. First, I'm going to import pg from pg. That is the package we just installed. And then to connect to the database, we have different ways to do that. If we go this way, we are going to manage closing the connection, etc. Right? Another way is to make use of what is called pooling. This way, the client is going to handle spinning up a new client to database and closing it whatever as needed. In other words, it is easier to make use of the pool. So the way that works is we say const pool, or let me call this db to be equal to new pg.pool. Inside here, we pass the credentials for connecting to the database. In order to accomplish this, it means that you already have PostgreSQL credentials that you can use. Whether you installed PostgreSQL locally or you have some remote database as a service, whatever, that you can connect to. So you have to get your Postgres credentials ready before you can proceed. For me, I'm going to say host because I want to keep those information in .env file. I'm going to say process.env.db host. Later, I'm going to add this to a .env file. Let me copy this a bunch of times. Then the next thing here is port for the database. db port. To save us some time, I've paused the video and added these 3 more items. So I'll head over to .env and add these environment variables. For that, I have an example .env file which I can copy. I'll copy all these and create a .env file. Say .env in small letter .env and paste those things. Coincidentally, these are the credentials I have in the local Postgres database I have in my machine. So I'm going to leave this the way it is. You can change this according to your own requirement. For more information on different ways you can connect to the database using the pooling option, you can check the official documentation. I think there's an option to connect using connection string instead of all those things I specified there. The way it is now, these env variables are not loaded into the program yet. To make them available, that is right here, they are still undefined. To make them available, we need to use the .env. You want to do that as early as possible in the application. For example, I'm going to come to the server.js file, which is like the starting point, and say import .env/config. So this is going to load whatever we have here and make it available. Let me go back and export this db config so we can make use of it elsewhere. Export default db. Now that we have the code for db connection in place, let me revisit my so-called migrations. To run this SQL, this very SQL here, I'll just add a helper function. Let me create a file index.js. This is not like ideal way for you to do it, just a helper method for us to create this. You can just copy this, head over to your database and paste and run it there, and that also works, right? I just want to do it in a programmatic way. For that, I've pasted this code which I'm going to explain. First, we import the DB we just created, the DB connection, and then we import the SQL code here. And what is happening is that I have this function called run DB migrations. If this is anything confusing at all, just copy this, head over to your database and run it. It's going to create this table. But if you want to stick around, let me walk you through this. So to run that SQL that we imported, I'm going to connect to the database using a single client, right? Because we want to do what is called transactions. That means if there's an error, we roll back the process. That's why I'm doing this. To run transaction, you connect to only one client. instead of the normal connection pool. You can check the documentation once again to understand this better. These are just comments you can remove. They are not part of the process. These are just comments. And then we say client, which is this single client, dot query. We pass the SQL query we want to run. If everything goes well, we commit that transaction. If something goes wrong, we roll back the process. That's just what is happening here. And finally, we manually close the client because we are not using the pooling we saw earlier. So that is all that is happening here. I'm going to leave this file here. Now let's go ahead and try to connect to the database and also run this little helper here. For that, I'm going to head over to server.js file. The first thing I want to do before starting the server is to call that function that runs the migration. Make sure to import that because that returns a promise. I'm going to await, right? We want to make sure that first, database connection is okay. Secondly, the migrations run successfully before we proceed with starting the application. The name of my database is demo, and if I check right now, you see that there is no table inside it. Let me show you. PSQL demo, not dino. So \dt, there's no relations inside here. There's nothing created inside it, but the database exists. Now let's go ahead and start this application and see what happens next. npm start. I have an error somewhere. Let's understand what is happening. Database dev does not exist. So this error is because the .env file over here in .env file, what I have is db_name, but in the connection I say db_database. So this guy is undefined. Let me correct that. I will save and we check again. We can see that this time the migration started and ended and there was no error. Now we'll go back and check if there is something in the database. You can see we have this table to dos, and if you check the \d+, I think to dos, if you check that, you can see the fields title, status, ID. According to what we have here, create table, to dos, ID, title, status. So our connection to the database was successful and this table was created as well. With the database ready and the table created, let's go ahead to implement the codes for the CRUD operations. For that, I'll head over to do folder. What I want to do is to have the code for talking to the data source, in this case the database, to be separate. For that, I'm going to create a file. Let me call this to do repository.js. In this file, I want to have the code for insert data in database, fetch data, update, delete, whatever. I will go ahead and import db from the db file. And then I want to have a function for create, that is to insert a record in the database. This is going to be async. To create a new record, we are going to take the title and status. This ID is primary key auto-generated column, so we are not going to insert that. So this is going to expect to have title and status. The ID is auto-generated. And then I want to have the SQL statement for performing this operation. Let me call it query. I'm going to say that the query is, let me use caps here, insert, oh, there should be equality sign here, insert into to dos, and then the columns, trying to make this more readable, title, status, and then values. So we are going to parameterize this, just some security measure. Instead of bringing this title and put here, we put some kind of placeholder that we are going to substitute, right? This is just an SQL stuff. You can learn that in the Postgres or the PG client documentation. We want to return the inserted record immediately after the insert to the client. For that, we can make use of this returning all. This wildcard is all. You can return specific columns if you want to, just like select statement. I'll put semicolon here. So we have our SQL. How do we execute it? To do that, I'm going to say const result to be equal to await db.query. We pass the query we want to execute. This is going to return the result, but in the form of array, right? What we want is it's going to be array of one record because we inserted only one record. So I'm going to return result dot rows, not row count, rows. Come on, the only row that is there. We are going to have the method for update, delete, find one, find all, etc. But for now, let me just export and test what we have. So I'm going to export default. We have this create here. Then I'll head over to do router. For the method to create a to-do, what I'm going to do is first let me import to-do repository from to-do repository. Interesting. How did he know that is to-do repository? Okay. So we have to-do repository imported. Then what I want to do here is await to-do repository.create. We pass request.body, because in the request body we are going to specify the title and status for the to-do. And then the response is going to be 201, the status when we create a new record, and of course the returned data from that operation. Our first endpoint is ready, so let's go ahead and test it. I'm going to use Postman as the client. This is the endpoint for create new to-do, localhost 3000/to-dos, because where we mounted the to-do router, we mounted to the path to-dos, and this endpoint just has slash. There's nothing that comes after to-dos. All right, I have the to-do title and the status. I'll send over the request. What happened? So the problem here is that I did not supply the replacements for these parameters, right? We're supposed to have a second argument to this dot query. We pass an array. This array will contain what we're going to use to substitute for these parameters, for these placeholders. The first one, title, points to this $1 sign. So I'm going to put title here. The second one is for status. This way, these values will be substituted for this and this one for this, and each one of them correspond to the respective columns. All right, that's not where I want to go. I will send the request again. You can see that this time we get success response 201 created. Let's check the database to see that the record is there. I'm going to say select all, come on, from to-dos. So you can see the record we have right there, write code and with status ongoing. Now we have a proof of concept, sort of, that we can use this DB connection to execute SQL in the database and return the result. To save us some time, let me pause this video and add the other SQL and functions, then I explain them to you one by one. Alright, so I added the other functions and this is what is happening there. The next function is find one. This is going to find one to do by the ID. And the SQL is simple. We say select all from to-dos where ID is this parameter, which of course we replace with the actual value here. I'm putting a plus here because in the URL, this is going to come as a string, right? This is just to cast it to a number, from number string to actual number. And like before, we return the record because this is just going to return only one record in the rows in the array. And then we have perhaps the simplest one, which is to find all to-dos. And the SQL is simple, select all from to-dos, and that is it. This is going, we are expecting 0 or multiple records, right? 0 or 1 or multiple records. So it is okay to just return the rows that are returned from that result. Also, we have update one. So the update one function takes the ID of the to-do we are going to update and then the data for title and status. The SQL is update to-dos, set title equals that placeholder and status the other placeholder where ID is equal to the ID supplied. Like in the create, we are returning the record that we updated. So the arguments are ID, we are casting this to number once again. That is the first guy there. You can see the placeholder here, $1. And then the title is the second one and status is the third one. And like before, we return the one and only record in the returned rows. For delete, we say delete from to-dos where ID matches the ID that is supplied in the argument, and we return one row. Finally, I just export everything. So that is what we have for the to-do repository. What we can do now is just to go over to the router and make use of those methods. So let's do this quickly. For get, this is going to get all the records, right? I'm going to just say that result is equal to await to-do repository.find all, and we just return the result, straightforward. Then get one by the ID, we are going to say that the result is await to-do repository.find one. We pass the ID as request.params.id because that is what we specified here. You can cast this to number because this comes as a string, by the way. You can see it's a string, although we already taken care of this in the function to find one. The next one is going to be to update. This is going to be put. This one is get. This one is put. And then the ID of the to-do. So we do something similar. Await to-do repository.update one. We pass the ID again, request.params.id. You can go ahead and implement validations, middleware and stuff for this, but this should be okay for our demonstration, right? We're not validating the incoming request. And finally, we have for delete, you can say that this is a way to do repository.delete one request.params.id. All right, so we have all the endpoints for CRUD operations ready. Let's go ahead and test it. We have already seen the create to do endpoint, but let's just try it one more time. Like another to do is to eat food. This is pending. We walk first. I'm going to send this. You can see we get the result and the ID is changing. 2 times I sent this and we have ID 2 and 3 because we already have one before now. Then for find all, this is going to be to/todos endpoint, a get request. Right now we have 3 to-dos. write code, eat food is repeated twice. Let's go to find one. I'm going to find to do by the ID 1. I send off the request, we get the to do. And then for the update, I'm going to update to do with ID 1. Instead of write code, it's going to be write JavaScript code. I will send the request. What happened? So I get an error. Let me see what that error is saying. Oh, we need to pass a second argument here, request.body, right? Because according to the function signature, the first item is the ID, the second one is the data. All right, that should solve the problem, I guess. I will send the request again. You can see we get the updated to do, and if we find it again, you can see the update was applied. Finally, I'm going to delete one of the to-dos, the one with ID 3. That is this last guy here, the duplicated one. I will send off the request. That is deleted. Find all again, you can see that the to-do is gone. Alright guys, so we have accomplished our goal for this lesson. I hope it makes sense. Until next time, enjoy coding.